Hi, this is Kristen. I've gotten a few questions about some of the reactions on the practice exam that I thought I'd go ahead and just go over and share with the whole group. Um, when you're doing the reactions, one was on the simpler reaction that is given amide formation, and then the very last question that is amide hydrolysis. Now, first of all, on the exam that you've seen, I've given the name of the reactions, and as you've seen on the quizzes, I don't have to give the names of the reactions. You can tell just by the reaction functional groups that are present what reaction has to be. So for example, in this one, well, it's told it's amide formation on the practice exam. I'm given here carboxylic acid and an amine, and the only reaction that uses a carboxylic acid and an amine going forward is amide formation. So I know that my functional group here needs to have that amide group in it somehow. Excuse me. And then as I'm going through and what other products do I have, what does the rest of this look like? When I do amide formation, my new bond here is this CN bond, right? This is my new bond. And that's my only new bond. This is this N here is here. This is this carbonyl, CO double bond here. What I break in this process is I lose water. I lose an O and then the H that's on it. And I need one other H to go. And that H is going to be where this nitrogen has to connect to the C. So I'm going to break an H there. Then what else goes on to my product is just going to be everything that's there. Anything that doesn't have an X is still going to be on my product. So here on this carbon, I'm going to have a CH2, CH3. So I'm still going to have those atoms. And then over here on the nitrogen, I'm still going to have this group here as well as this H there. Now, yes, this is drawn in a different direction, but it doesn't matter as long as the connections are the same, right? Direction doesn't matter, connections matter. So as I do my product here, this is my product. Double check. I don't know how to get rid of any carbons yet. So how many total carbons do I have in my reactants, or the top part versus the bottom? I have 1, 2, 3 carbons. So I have 3 here. Over here, I have 1, 2 carbons. 2 here. I better have 5 down here in my product. And I do. I have 1, 2, 3, 4, 5. And so that's my answer for the amide formation. The very last question is exactly the opposite of the reaction I just talked about. It's amide hydrolysis. And so in this reaction, it's the exact opposite. Just like we talked about, the CN bond was what was formed there. Well, in this reaction, I'm starting with the amide. And that CN bond is the only thing that breaks. So I could redraw this structure over here, but because I have a whiteboard in front of me, when I'm trying to decide what my product looks like, if I was redoing this problem on the exam, my first step would just be copy the entire thing exactly as it is, except for the only bond that breaks. And the only bond that breaks is this CN bond. So I'm going to erase that. And so I have this, I'm going to draw the product itself here. I break that CN bond, but that's the only bond that breaks in an amide hydrolysis. Hydrolysis, I'm going to add water to it. So there's 2 ways to think about this. I'm going to add water, so I can either add H or OH to either of these spots that I've taken away the bond. So I have to add something here, and I have to add something here. If I would add OH over here, that is a bond that is not one I've ever seen before. I cannot name this functional group. You've not seen it. It is a functional group, but not one that's common in biochemistry. And if I would do that here, I would have that and an aldehyde. But amides aren't formed by aldehydes and whatever the heck this is. So that should tell you that you put those atoms on wrong. The functional groups that make up amides are, as you saw in the previous question, a carboxylic acid and an amine. So my product, when I'm breaking up an amide, should be a carboxylic acid and an amine. To do that, I still have water, H2O, to put somewhere, but to make a carboxylic acid, I need to add the OH to the carbonyl group and an H to the N. So I have my carboxylic acid group here and my amine group here. If I draw this out in straight form, it would look like this. It doesn't matter which one I draw. Both of them are completely correct. But don't let it scare you that these carbons connect your carboxylic acid to the amine. I don't break any of those bonds. You don't know how to break a carbon-carbon bond, but you can break the CN bond. Just because they're connected in the same one doesn't change anything. Let me know if you have any more questions or if I can help you at all.